Okay, so we're going to do this numerical test today. Class 10, chapter 12, electricity. Okay, so this example 12.1, let us go there, page 211. Let us go slow, example 12.1. So open your textbook to page 211. Okay, there a question is there, let me read the question. A current of 0.5 ampere drawn by a filament of an electric bulb for 10 minutes. Let's just write that down. Since a current of 0.5 ampere is drawn, means taken out, drawn means taken out, for shortening that words there, 10 minutes. So as we do in this test portion, keep the first three formulas in mind. First one is current I equal to charge by time Q by T. Second is potential difference or voltage is equal to work done divided by charge transferred. And the third one, the Ohm's law equation, that is Ohm's law, V is equal to I into R, current into resistance. So keep this in mind as we do. Okay, so here, as we read this, here ampere means the SI unit of current. So we know ampere means current, so that is denoted by I. 0.5 ampere is the current. So remember that ampere is the SI unit of current. Okay, then here 10 minutes means obviously time. Okay, and we know that the SI unit for time is seconds, so we need to keep this in mind: hour, minute and second. So you're going to change minute to second, you're shifting one place to the right, so multiplied by 160, because 1 minute is 60 seconds and minute will change to second, so this is 600 seconds. Question is saying find the amount of electric charge. So charge here, as I said, current, charge, time, potential difference, work, charge. So charge is in our textbook denoted by Q usually. This is the charge that we have to find. Okay, now if you use the same first formula there, we know current I is equal to charge transferred divided by the time taken T. I equal to Q by T. So we have to find Q, so don't touch the numerator and shift this denominator, then it will multiply with I to become IT. So I here is 0.5 ampere, T is here 600 seconds, so we read there is equal to here Q. Now we know 0.5 means half of anything, like 0.5 into 2, then this 2 will become half. 0.5 into 6 likewise, half of 6 is 3, so anytime a number is multiplied with 0.5 becomes half itself. So half of 600 is therefore 300. 0.5 into 600, 300. Then SI unit of charge Q is coulomb. So ampere into second is always coulomb, so we write your coulomb Q. So SI unit of charge is coulomb. Therefore the charge, according to the question, charge flown or that is flowing, Q is equal to 300 coulombs in the SI unit. Capital C it is denoted by. So that is the first question. Okay, the next one, as we go on, question number 3. Listen carefully as we do. Page 111. 211, sorry. Calculate the number of electrons constituting 1 coulomb of charge. Now we know from our general knowledge that an electron contains, contains a charge of 1.6 into 10 to the power minus 19 coulomb. This is the smallest charge known, that is the charge found on one electron. The smallest known charge in nature is 1.6 into 10 to the minus 19. So this is the charge on one electron. We know that. So they're asking you number of electrons making 1 coulomb. So there is, we can change this one as there is 1.6 into 10 to the power minus 19 coulomb charge. This is charge, coulomb means charge, is contained in how many electrons? This much is in an electron, means in 1 electron. So this much charge, the smallest charge known to us, is found inside 1 electron. So therefore 1 coulomb charge is contained in, just like the mango method, you see here, we know that 5 mangoes cost rupees 50. Then how much will 1 mango be? Common sense? Yes, 10 rupees. How do you get that? Right side divided by left side. So rupees 50 right side by left side, then we get 10. So our answer is right side divided by left side. Similarly, our answer here will be right side divided by left side. This one. And the left side you need is coulomb, that we cannot bring right side. The right side we are using electrons, so we write here electrons. So we know 1 coulomb charge is contained in, question is saying how much electron will be found in 1 coulomb. So 1 coulomb contain how many electron? Well, that is the answer. This is our answer. Let us simplify it. Now here, if you shift this here, denominator, if you shift it to, okay, you can write like this also, okay, numerator, then the power minus 19 will become plus 19 electrons. Okay, now there is 1 decimal in the denominator here, 1 decimal place, so it's better to remove it. So let us, 1 decimal place means by 1 0 up and down you multiply, and 10 ones are 10, okay, into 10 to the power 19, same, nothing touch. Then 1 0 means this decimal will be shifted to the right side because of this 1 0, so no more decimal. Now let us cancel this. 2 8s are 16, 2 5s are 10, and this much electrons. So 5 divided by 8, let us do that. And smaller than 8 means 0 point, then 0. 6 are 48, 2 remainder. And point means you can put 0 here, 8 2s are 16. And 4 remainder, so write that one 4. And then point means again 0, so 8 5s are 40. So exactly you're going to get this 5 divided by 8 will be 0.625. Listen carefully to this part. It's not hard, okay? But you need to think into 10 to the power 19 electrons. So that is can be your answer. But usually answer is expressed in the standard form, means decimal right after the first digit. So if you want to bring here, then 6.25, then that can happen only when you divide by 10. See, divide by 10 means again the decimal will move back to the original. So you can do like this only when you put a 10 in the denominator, and this portion is changed to this. This here is the same as this, because we want to change the standard form. Multiply to this has not been touched, so 10 to the power 19 electrons. I hope you're getting it. That way, we are going to get here 10 to the power 1 cancel, so here 10 to the power 19, 1 power gone means 19 minus 1, 18. So now 6.25 6.25 into 10 to the power 18 electrons will make 1 coulomb. So the answer is 6.25 into 10 to the power 18 electrons. So this is the most preferred way of writing answer standard from shifting, making the decimal go after first digit. Okay, that's your answer. Now 2 more questions. Example 12.2. So let us go there. Example 12.2. Okay, so let us see the page 213 now. How much work is done? So here, start writing. One way to do it is also work done is W. How much work done they're saying, so we have to find this. In moving a charge of 2 coulombs, so charge is Q. We know charge is usually denoted by Q. The unit is coulomb, so this is the charge involved. Then across 2 points having potential difference, so potential difference is usually denoted by V. I repeat, current, charge, time, potential difference or voltage, work done, charge, potential difference, current, resistance. Okay, so get familiar with the physical terms there. So this is potential difference is 12 volts. The SI unit of potential difference is volts. Is the potential difference between the 2 points. So we have to find W. So the first formula that will match is 2. So V equal to W by Q, because V and Q are there, you see. So we want to find W, so V into Q. Q will go up. So V is 12 volts, as you can see here. Q is 2 coulombs. Everything is, we have to make sure it's an SI unit. Okay, that is called the work. So here 12 twos are 24, and the SI unit of work or energy is joules. Okay, say joules, written in short as J. So volt into coulomb is always joules. So therefore, work done here, W equal to 24 joules to move the charge 2 coulomb from one point to the other point. Okay, so next 3. Question number 3, page 213. Let me read the question for us. How much energy is given to each coulomb of charge? So here E and W, energy and work are same. Okay, is equal to, question mark is the energy that we're going to calculate. Each coulomb means charge, so Q equal to, each means 1, so 1 coulomb is the charge. Each coulomb passing through 6 volt battery. Even though they didn't mention, volt is potential difference, so we read V. 6 volt is the potential difference. So we have here W or E, Q and V involved, so QV. Again, second equation, so you write your since potential difference is work done by charge transfers, so we need to find W, okay, which is actually V into Q. So that gives you 6 volt into Q is here 1 coulomb equal to W or E, same thing. So that will give you W equal to E equal to 6 ones are 6 joules. So therefore, energy given in this case E equal to 6 joules. So these are the 4 questions. You can go and give the test. Okay.